All right, hey stats. This is for this video. You're going to need your notes for section 8.4. We're going to go through this. This is only one page, so that's kind of exciting. And there is a homework assignment that goes along with this. It looks like this: testing claim of variance or standard deviation 8.4. Okay, so I'll kind of go through that as we go along here. But section 8.4, we're doing variance and standard deviation. 8.3 was mean, 8.2 was proportion, so this is kind of the same procedure again. Here is going to be how you calculate your test statistic, okay? And it's kind of based on that chi-squared. Chi-squared is how we pronounced him, this x-squared value, okay? He is pronounced chi-squared. Let me get it unfuzzy for you. There we go. Well, maybe not. So we're only going to do the critical value method, and we'll kind of go over that one. I know that you guys like the p-value method better, but the p-value method for variance and standard deviation is ugly. And then we're going to do confidence interval method down below here for this one. So we're only ever going to do critical value and confidence interval just because those are the easiest ones for standard deviation. Okay. So listed below are the heights for a simple random sample of female supermodels, and then they list out who all the supermodels are. Use a 0.1 significance level. And that tells me this: 0.01 significance level. Okay, I'm going to write stuff down as we go along. Standard deviation. Okay, to test the claim that the supermodels have a height with a standard deviation that is less than blah, 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 less than 7.5. Okay, so my claim is that the standard deviation is less than 7.5. I don't know why would they put equal to. That's kind of confusing. That is less than Q is 7 point, or not Q. Sigma is less. So basically what they're doing here is they don't like a lot of variation in their supermodels. They like them only to be one height, one body type, tall, skinny, that's it. So they're basically saying that they don't vary very much for the height of supermodels, okay? Does it appear that heights of supermodels vary less than the heights of women from the population, right? So this is going to be the sample that they're giving me, and we need to kind of pick out information that we have from here. Let's fill in our null and alternative hypothesis. So in this case, it's going to be that our standard deviation is equal to 7.5, okay? And here the standard deviation is not going to be equal to 7.5, okay? And in this case, it's going to go with the bottom one. If it's not equal to 7.5, it's probably going to be less than 7.5, just like we're claiming, okay? Let's fill in what our bell curve looks like in this case, okay? If we're doing less than, think about if we're doing left tail, right tail, two-tailed, less than is going to be just the left tail, okay? That's what my less than 7.5 is going to look like. And then there is 1% in this tail, okay? Which means that there's kind of an imaginary 1% over here. And we're looking at 98% living in the center, okay? So that's kind of how that bell curve's going to look here, okay? Let's gather up some more information. They give me this set of numbers here. And I have to gather up all my data from that. So looking at the formula that we're going to have to compute next, okay, I need to know what an N is, I need to know what an S is, and I need to know what my standard deviation is. So in this case, S is going to be standard deviation for my sample. Let me write that in here. Sample, standard deviation, okay. The sigma is going to be my claim standard deviation. So this is going to be the 7.5 that we're comparing to. And then N is the number in the sample. Number in sample. Okay. All right. So there's that information. I'm going to go ahead and start figuring out some of this stuff. So N, we need an S and we need an N. Those are the two things that we need given this information. All right. N, they don't tell me how many they're surveying. But I can figure it out by just counting. So 1, 2, 3, 4, 5, 6, 7, 16. My video is kind of delayed a little bit. 16 is my N, okay? And then S, I've got to figure out. So let me go to my spreadsheet here. Here's my taxes. This is not a Google Sheet, but this is my husband's taxes for the year. We'll just do it on here. 178. 177. This is an Excel spreadsheet, by the way, but they work just the same as Google Sheets. 175, 178, 175. This is very confusing. Let me check that. 178, 177, 126. Okay, so I do not need average in this case. I'm just going to do equals standard deviation. And they're going to calculate standard deviation for me. And it is 1.84. Holy Toledo. 1.84. We are comparing that against 7.5. Wow. So basically we're trying to figure out, is 1.84 lower than 7.5 or significantly lower than 7.5? Maybe if that was like 7.4, they would say, that's pretty close, we're going to go ahead and conclude this. But in this case, I'm going to say that this is going to be a hard reject because 1.84 is definitely really significantly less than 7.5. So let's see if we end up rejecting this at the end. Okay, so let's do my, before we type in this formula or calculate this formula, let's go ahead and figure out what our numbers are here. Okay, so I need to figure out what this guy is and basically that guy. We don't really need this one, but it kind of helps to do that at the same time. And so what we're going to do is we're going to use the chi-squared table. I hope you guys all have that. That's the only one that is not laminated in your book or in the sheets that I gave to you. It was the one that we just wrote on, I guess, and I did not get it laminated. I'm going to open it up in my book here. If you guys need this chi-square table and don't have it already, let me know. Like, put a comment down below, and I can. Yeah, let me do this. Put a comment down below, and I can take a picture of this table and like send it to you or something. So, what we need to look at is degrees of freedom, and then we need to look at 98%. So each one of those, 98%. Since we have 16 people, our degrees of freedom is going to be 15. So we're looking at that one. And 98% is going to be 5.229 and 30.578. So 5.229, 5.229, and 578. Okay, those are going to be the two numbers that we're comparing against. All right, now let's go ahead and impute him. So 16 minus 1. S is going to be 1.84 squared, and then 7.5 squared. Okay, I'm just plugging this into this formula up here. All right, now let's go ahead and type that in. I'm going to do 16 minus 1 in my head. So I'm going to do 15 times 1.84 squared divided by 7.5 squared. And that's going to give me 0.9, I just erased it, go back, 0.903, we'll say. That's what my chi-squared that I'm comparing to, okay? All right, now all I have to do is I have to just compare that to where it's located on the table. So if this is like 0 and this would be like a really large number over here, so 0, 5, 30, where is 0.903 going to fit? It is between 0 and 5, so he is in the bad region, okay? And that means that we are going to reject, which is kind of what we had said before. We reject the null hypothesis, which means that our claim is valid, okay? There is not very much variation or anything like that in the heights of these supermodels. They're basically picking them out so that they're exactly the same shape and size, all of them. Okay? All right, so now we're going to do the same thing. We should get the same conclusion again, but now we're going to use it, or do the confidence interval method, all right? So my claim, or my, let's do null hypothesis, is that the standard deviation is equal to 7.5. I'm just copying this from above. And alternative is that standard deviation is not equal to 7.5, or that it is less than 7.5. Okay, I'm just copying that from above. All right, and now we're going to go ahead and figure out what each one of these numbers is, doing our confidence interval. Okay, so the first confidence interval should look like 16 minus 1, standard deviation squared, 1.84 squared, all over that right side chi-squared value. Okay, the right side chi-squared value was this 30.578. Okay, so we're going to take 30.578 and we're going to square him. Okay, now this other one is going to look exactly the same, except he's going to have a different bottom number. He is going to be the 5.229 squared. Okay, and we're going to see how this confidence interval method compares to what we did up here. Okay, so that first side, second square root, make sure you put in lots and lots and lots of parentheses and do some stuff in your head if you can. So 16 minus 1 is 15, okay, times 1.84 squared, that's my top number, divided by 30.578 squared. And my final parenthesis, and I get 0.233 is less than this guy, which is less than the other number. Okay, now since I have it all typed in at one shot, I'm just going to go ahead and change my numbers up here. This is 5.229, and delete a number at the end, squared. Okay, and I get 1.363. Okay, if we round to 3 decimal places. All right, and so this is what my confidence interval looks like. It says that my standard deviation should be between 0.233 and 1.363. So how does that compare to the hypothesis that the standard deviation is actually 7.5? This is not true. This tells me that we're going to reject the null hypothesis, and the claim is valid because the claim went with this guy. So by rejecting this thing, by saying that that's false, we're saying that the claim is actually true, okay? Which is exactly the same conclusion as we got up here, just using a different method, right? Now this seemed like it went faster because we had already done the work up here, basically. We had already found these numbers, 5.229 and the 30.578. So that made it go a lot faster, okay? So comment, I guess, if you know that you're going to need a copy of this chi-squared table, and I can get that posted onto Google Classroom for you. So there is that. On your homework assignment, what I want you to do is, I'm going to give you 2 days to do this, so I'm not going to post a video tomorrow. Or I might post a video of one of these being solved, or helping you solve one of them. What I want you to do is 1, 2, and 3, do this whole side like example 1, so the critical value method. I'm going to put a CV next to each one of those, critical value, critical value, critical value. And then the back side, do the confidence interval method, so like example 2. Okay, so do each one of those. So I might go ahead and post a video tomorrow, and I'll do one of these kind of with you. But I won't post anything new, so you'll have today and then tomorrow to finish this up and send this to me, okay? So there's that.